Alright, this is going to be our quick lecture on water pollution. Half of our pollution notes, the second half will be air pollution, which we'll cover in a couple of days. To quickly get the basics out of the way for water pollution. Water pollution itself we define as just contamination of bodies of water, usually with substances produced through human activities, and those substances have to negatively affect the organisms. It doesn't necessarily just mean that we're dirtying up the water or making the water quote-unquote unhealthy for people, but we have to look at it in the grand scheme of environmental damage. That water pollution is anything that is going to change that body of water's natural physical makeup. So when we look at water pollution, one of the things that makes it difficult to manage is that most water pollution comes from what we call non-point sources. Basically large areas that are not directly dumping into one particular spot. Point sources, which would be distinct locations where waste is going directly into a waterway, but things such as runoff, especially from suburban areas or agricultural operations, are considered non-point because we can't pinpoint the exact one location where that pollution is entering the waterway. So that you see to the left, that's an example of point source. If there is a manufacturing building or an industrial building with a large pipe that is specifically pouring out wastewater into a body of water, that's what we call point solution, because we can identify that one source. Farming operations, this entire area is a farming operation, so that means that since the pollution can enter from any and all areas along the stream, that's considered non-point source. And those are harder to tackle because it's not just stopping stuff from coming from one location, you have to change entire practices. Alright, so before we get into the pollution itself, we're going to talk about human wastewater. Basically, water specifically from human production, human bodily functions. So this would be toilet water, bath water, dishwasher, sinks, anything like that. Now, there are reasons to be concerned about human wastewater, and the reasons are the waste themselves can contain bacteria, or they incite large growths of bacteria by providing a medium for them to attach and feed on. It creates a large oxygen demand in the water. Large oxygen demand means less oxygen available for the other living things. Nutrients that are released from wastewater decomposition, such as nitrates and phosphates, the same things that are necessary for fertilizer, make the water more fertile, meaning that plants, specifically algae, plant-based algae, photosynthetic organisms, can use that oxygen for cell respiration. Now we think, well, wait, they're photosynthetic, so don't they make the oxygen that they use? No. Since the photosynthetic organisms are on the top layer, the oxygen they release is released into the atmosphere, for the most part, while the oxygen that they're using for cell respiration it comes from the water, so we deplete the oxygen availability in that body of water. And then, of course, we're concerned about disease-causing organisms, bacteria and viruses that could make individuals, specifically humans, sick. Now, a measure of water pollution through waste is usually biochemical oxygen demand, like we did in our lab. A lower BOD value means less polluted. There's no change over time in the amount of oxygen available in that water with no inputs. And a higher BOD value means it's more polluted. It means that there's more stuff in there for organisms to break down and or more decomposing organisms in that water supply, which would use up that oxygen more. Now, eutrophication is when we basically increase fertility of the water. So by adding nitrates and phosphates that plants need in order to grow, especially this happens a lot with fertilizer use, fertilizer runoff from farms. You get rapid algae growths, which results in a rapid use of oxygen in the water. That algae then die, or the other organisms in the body of water die, and they get decomposed by bacteria, which would then use more and more of that oxygen, which would therefore result in what we call a dead zone, where life cannot survive because there isn't enough oxygen in that body of water. Alright, the way that we deal with human and animal wastewaters for the most part, in terms of humans, there's basically two methods. There's septic systems and then there's sewage treatment. So septic systems are basically when you have a large container, which would be this big gray box here, that receives the wastewater. It has bacteria in it that will break down, waste organic products into, basically a sludge that sits down at the bottom, which can then be emptied out. The wastewater itself will then exit and go into what's called the leach field, which will be a soil composed of different different permeabilities that allow water to percolate through at a particular rate, and that will basically naturally filter out the wastewater before it enters, let's say, a well water system or a groundwater supply or a lake, river, or a stream of some kind. It's basically a second line of defense. So most of the waste is captured here, but any remaining waste is captured in the leach field in the ground itself, before that water itself, as it percolates out through these rings and into the soil before it can reach any other body of water. Now, a sewage treatment plant is basically for places that have pipes and running internal water systems from a centralized location. Septic systems like these are usually, if you have a well, you usually have a septic system, because you're talking about getting your water not from a centralized location. Sewage treatment plants are designed for a lot of suburban areas that get their water from one particular water source. So as that water is basically pumped out, so we're talking about flushing the toilets, draining bathtubs, doing dishes, sinks, things like that. These things all go to a water treatment facility. So primary treatment is a lot of bacteria that will, again, break down waste into solid material, sludge. Secondary treatment involves a lot of aeration, more addition of microorganisms to basically, again, filter out any additional solid material. The solid material is basically heated up to remove the water from it, and that thickened sludge, which is mostly, broken down organic matter from human waste, is then basically either carted off and, can be used for fertilizer. It can be burned for heat. It can be, basically, in terms of biomass, a lot of different applications for leftover human waste. The water itself, as it's being constantly treated with microorganisms and chemicals, very, environmentally friendly chemicals to remove any kind of bacteria presence or pathogen presence, is finally irradiated with ultraviolet light, which kills any leftover bacteria before it's released into a water supply, which can then be, again, or a reservoir, which will then take it, where it can be used again. The problem is this process doesn't necessarily filter out all the nitrates and phosphates, so areas that have high runoff of that stuff. Do you have that? Now, again, with the water as it's being treated, if you have areas that are high runoff areas for a lot of suburban fertilizer use in this case, or you are, let's say, downstream of an area that has high agricultural use and a lot of fertilizer use, then one of our potential issues is those nitrates and phosphates don't get worked out of the system here and end up back in that water supply, can lead to algae growth. Manure lagoons are basically used for farm operations. It's also very similar to what they use when we watched Gasland in terms of the wastewater used in fracking. Basically, you take a large pit and you line it with, rubber to prevent anything from leaking into the groundwater, although we know it's not 100% efficient at doing that. You fill the pit, in this case, with bacteria, and the manure gets broken down and, into a sludge, basically, and that sludge itself is then taken back out of the pit and used as fertilizer on the farm. Now, other water pollutants besides wastewater itself, would be things like heavy metals, usually from mining operations, oil pollution, which we'll talk about on the next slide, solid pollution, which would basically be garbage entering waterways. We know that garbage can be dangerous because it can interfere with organisms as on their day-to-days. It can block sunlight. Sediment pollution, same thing, can cloud the water, reducing photosynthesis. There's also thermal pollution and noise pollution. Thermal pollution can happen when you have an operation that uses a lot of water, let's say like a power plant nearby. a body of water, and if that water itself that's being re-entered or used up is very warm, it warms up the bodies of water around it. So we see here, the one thing to note on oil pollution is that when we look at both North American and marine waters, natural seeps, meaning that natural leaks of the ocean, are actually a larger chunk of the amount of oil that's considered oil pollution. You'd see some of it is the result of consuming of petroleum, basically using it. So we're talking about excess polluting that way. The extraction process and transportation is basically very small compared to, especially on the whole, the natural oil pollution thing. So remedying that is a big issue, especially given our current excessive use of oil. We know that we need a lot of it, so we're not going to stop mining for it, which does result in some natural seepage as well from those places that we extract it. But things like booms that are basically used to round up the oil to keep it from spreading, or chemical dispersers, even bacteria that have been engineered to consume that oil, are a couple of methods of oil remediation. Here we see a river in Indonesia that is polluted with physical garbage. This is an example of sediment pollution entering an area presumably through runoff here. And this is thermal pollution, so you could see that, well, it looks, yes, the water here is safe for these individuals to actually be swimming in, but the natural water supply probably wasn't nearly this temperature. It's probably the result of excess water being let off by this power plant here, which has turned this into a nice hot body of water as a swimming area. But in terms of its natural environmental qualities, it should not be that warm. Now, water laws, you definitely should know these two, the Clean Water Act and the Safe Drinking Water Act. Clean Water Act basically established what acceptable limits of pollutants would be, and what makes this difficult to enforce is that, going back to that non-point source pollution, let's say farms are responsible for increasing nitrates, and a body of water has a very high level of nitrates. Well, how do you know which farm in that farming area is specifically responsible for that? Since it's non-point source, it's very difficult to manage. Adhering to and enforcing the Clean Water Act can be very difficult at times. The Safe Drinking Water Act does the same thing, except instead of natural water areas, it establishes contaminant levels for different elements and substances that would make it considered safe enough to drink. So here we see a couple of examples of maximum contaminant levels. Basically, anything more than that in the water is considered unsafe to drink. You see with microorganisms, bacteria, the answer is 0. There should be no levels for these parts per billion. For certain inorganic chemicals, metals here, we see that for arsenic, it's 10 parts per billion. Mercury is 2, so anything higher than that. Some volatile organic chemicals here like benzene and atrazine, which are the result of some industrial processes, still very, very low. And here we see basically cause and source. This is a good little chart to look at, basically to get an idea of where particular things like pathogens, metals, oxygen depletion, where those things are the result of. Right, that's it for our water pollution. We'll talk a little bit more about some of the specifics from that in class. And then for our next class, you will have one on this chapter 15, air pollution and ozone depletion. So this one will be a little bit longer, a little bit more technical, because of the exact methods of air pollution entering the atmosphere and specifically focusing on ozone depletion as that is relative to climate change.